Geometry, Day 2, Chapter 1. We're looking at the distance between two endpoints of a segment in a figure. We have point A and point B. We could be looking at the distance between that, and a notation would be AB. Notice that this notation does not have a bar above it. It's just the AB letter with the equal sign. When we look at the value, this is called the segment addition postulate. We're going to do a lot of addition postulates throughout the year. In this case, we're looking at the two small parts that add up to equal the big part. So AB plus BC equals the whole thing, which is AC. That concept is called the segment addition postulate because you're adding up two small segments to equal the big segment. So AC is made up of two small pieces. So in this case, we're going to look at the value from the beginning starting point to the destination. If we first look at it from the segment addition postulate, we would say that the first step was SR plus the second one was RD, and that should equal SD. We don't put bars above those letters because these are value numbers that go in for each one. We can substitute in the values and then do the calculation, which is 151 miles. And we like to put our units in there at the end. Find the distance from the starting point to the destination. That would be 64 plus 87, which is 151. This is showing it using the segment addition postulate. Here we're going to be looking for the value of KL. Well, we can still start out with the segment addition postulate, which is JK plus the other small part, which is KL, and that equals the full thing, which is JL. Plug in the numbers we know for sure. 15 plus the unknown, we don't know what this value is, but we know that the whole distance is 38. So now we have a normal equation where we can subtract 15 from both sides and find out that KL equals 23. And we say units at the end because we don't know if they're feet or inches or miles. Here we're going to be looking for the value of QS and PQ. PQ is here, and QS you might be more confident about is there. So we actually have two equations to write. We have QR plus RS equals QS. We needed the value that was going to incorporate the QS. The QS is the value from here out to there. It's made up of two small pieces. So those two small pieces are 31, 30, and we still aren't positive what that value is. So now we can add it up. We find that 61 equals QS. And we could write units since we're not sure it's miles or inches. For the next one, PQ, when we look here at PQ, we notice that PQ is part of PR. So if we think about PQ and QR, that makes up something we know called PR. PQ is what we still don't know. You could put an X in there or just label it PQ. QR is 31. And we also know the other variable, which is the length of PR, which is 55. So now we're looking for the value of PQ. This is just a basic algebra equation. Again, we write down the word units because we're not sure if this is meters or centimeters or what that length may be. Now on the next page, we're going to look at the idea of what's happening if two items are equal, what's happening if two items are congruent. Here we're talking about segments. So segments are equal if their number value is the same. So if they're both 3 inches long, those are called equal measures. Two segments are going to be congruent if they are the same length, if they can lie on top of each other. Their actual size is the same. The shape or size is called congruent. The number that represents their measurement is called equal. For the most part, a congruent means equal. So the congruent symbol is a squiggly line with 2 bars underneath it. So it's 2 bars look like equals with the squiggly line on top, which makes this congruence. So what we're going to look at next is we're going to plot these different values. We're going to plot FG. So we go over 4 and up 5, over 1 and up 5. So we have G, we have F. So this is the length of one of the segments. Then we're going to look at HJ. 3, 3 is the H. 3, negative 2 is the J. So one way we can measure this, because it's vertical goes up and down, we can count that value. We can count the distance on the coordinate plane if the segments are vertical or horizontal. We can just count them. So 1, 2, 3, 4, 5. So GF equals 5. 1, 2, 3, 4, 5. HJ equals 5. So in this case, because their numbers are the same, we would say that FG with a bar across it, because we're talking about congruence, we're talking about shape, is congruent to HJ. We put the bar across it. When we're talking about a number value, we don't put bars above them, but when we're relating them to another segment, we do put the bars above it. We can plot our points here. 2 over 1 down, 4 over 1 down, and we have A and B. Plot points D and C. again, we have vertical and horizontal. So AB is the length of 6. CD is the length of 5. So now we know that CD is not congruent to AB because they're not the same length. 1, 2, 3, 4, 5, 6. AB is 6 lengths, 6 units. CD is 5. They're not the same. For even a trickier one, for our last example, we're going to look at RT. Now, we don't have a coordinate plane. We don't have plots to point. So a lot of times we can just make up a value like so. So we have R, we have T. This is going to talk about RS. So S is in between R and T. We don't know where it is in between it, but it's in between there somewhere. So RS is 2x minus 8. S to T is 3x minus 10. And you know that the whole thing is supposed to be 17. So now we can use our segment addition postulate that RT equals the two small parts. It doesn't matter if you put the RT last, if you put the RT first, and we plug in our numbers. We have 17, 2x minus 8, 3x minus 10, and group our like terms together. We'll add the 18 to the other side. And divide by 5. So if we're trying to find out the value of x, then the value of x is 7. Find the measure of each segment. The measure of each segment, RS, is going to be 2 times 7 minus 8, 14 minus 8, which is 6, and ST is going to be 3 times 7 minus 10, which is 21 minus 10, which is 11. Those would be the lengths of the segments when x is 7. And x would be 7 when the two values add up to be 17.